Hey everyone, this is Muhammad Nadeem and welcome to my YouTube channel. Today in this video, we will focus on the concept of the drift velocity. So let's start the video. Here we have a simple circuit which consists of the battery as an element and that is connected to copper strip. So here the copper strip. When the potential difference was not provided to this copper strip, so what was the motion of the free electron inside that copper strip? Now here we know that this copper strip will made up of millions and billions of atoms, and one of the atom from them is this copper atom. Inside this copper atom we have a nucleus present at the center, and there are large number of positive charges as proton present at that center inside that nucleus, and that positive charges is surrounded by large number of free electrons. So here in this case the force of this positive center and these near electron will be more, and that force of attraction as compared to this will be less as compared to this. So in this way the electrostatic force of attraction will be very low on this last electron of this copper atom from the nucleus. So here the electrostatic force and this last shell are in valence shell electron will be less. Therefore this valence shell electron is considered to be a free electron even at the room temperature. So this is the free electron, and this copper strip is made up of millions and billions of the copper atom, and each copper atom contributed to the free electron, and hence therefore we can say that this copper strip will consist of C of free electrons, because each copper atom contributed to electrons. So here is the C of free electrons. In other words, we can say that the C of the charges. Before providing the potential difference to this metallic strip, here the motion of the electron is random. Let's consider a single free electron here, and it is surrounded by other free electrons, and when this electron move, so when it move in this direction, it will collide with this atom of the copper and will change its direction in this way. When it reach here, the other free electron will be present there, change the direction of that free electron in this way, and then it change a direction in this way, and therefore here we say that the random the motion of the free electron when the potential difference were not provided to this copper strip, the motion of this free electron was is random. So here is the random motion of the free electron, random motion of free electrons. So when now we provide the external source as a battery here, the battery have a positive charge on one side and the negative charge on the other side. Here the electromotive force will develop the potential difference here. So here this is the positive, this is the negative, and having some potential difference. The electromotive force is responsible for creating the potential difference here, and due to that potential difference the electric field is developed inside this metallic strip. So here will be the electric field present inside this metallic strip, and this electric field will present at each and every point of this conductor. The formula of the electric field is the force per unit charge. So from this we can calculate the force, which is equal to the electric field intensity into charge. Here due to potential difference the electric field intensity is developed, and due to that this is actually the force exerted on these free electrons, and the direction is actually represent the direction of the force exertion on these free electrons. Now this free electron is in motion, and the one important point to be considered here is that the motion of this free electron will be the same throughout this conductor here. At each and every point inside this conductor, a force F will apply with the same magnitude. So here the charges will move at a same magnitude. So drift velocity is actually the actually the velocity of these free electrons when the potential difference were provided. So in this case, the drift velocity of the conductor is very low. It is up to the millimeter per horse. This is up to millimeter per horse. If the drift velocity is very low here, then how the electron pass quickly through this copper strip? The one possible answer for this is the electric field. Electric field is actually exerted at each and every point of this metallic strip, and the due to that same electric field everywhere inside this metallic strip, the motion the energy will quickly transfer from one end to the another end. And the second possible reason for this is that is due to the Domino effect. So here I'm going to write the name. This is due to the Domino effect. So Domino effect. Let we have a pipe here. Inside this pipe, we take the spares inside this pipe. We take the spares. This is the one spare, and it is this is the other spare, and this is the other spare inside this pipe. And in this way, all these spares are connected to each other, and in this way they reach the other end of this copper. So here if I insert ports on this side, so if I insert ports on only this first spare, this force will transfer to this spare, and then that spare will transfer the same force to this one, and in this way the applied force will quickly transfer from this spare to this spare. If we exert the force on this spare, this spare will give energy to this spare, and this spare then again give energy to this spare, and in this way the energy will transfer from this spare to this spare. This pair will not move from this end of the conductor to this end of the conductor, but actually the energy will flow here. So this sort of effect is called Domino effect, and this is used in daily life for the critical thinking and for other applications. So here the electric current also use that Domino effect. So if here we have the large number of free electrons, and if due to potential difference an electric field is developed, and due to that electric field the force will exert on the free electron, and that free electron will give their force or energy into the other one, and that other one free electron will give the energy to the next one, and in this way the energy will transfer quickly from the one end to the another end. So I hope you got my point. So this was the a little bit explanation about the drift velocity. So that's it, guys. Thanks for watching.